So in this clip, we're going to talk about orthonormal bases. And as a warm-up, we're going to see that an orthonormal list is an independent list. And so the proof for this one is straightforward, slick, and pretty. So we just begin by supposing that we've got an orthonormal list. And then we want to check that it's independent. So we suppose that there is a dependence relation. So we suppose that there's some coefficients ak such that the linear combination is equal to 0. Okay, well if that's the 0 vector, then it has length 0. And if its length is 0, then the square of its length is also equal to 0. And the reason why that's handy is because now we can use the Pythagorean theorem. So using it n times, or actually n minus 1 times, I guess, we can split this apart. And then using positive homogeneity, we have we can pull out each of these coefficients with the square. And then we have a sum of non-negative things adding up to be equal to 0. And so that implies that it must be the case that all of these coefficients are equal to 0. And so then that tells us that our list is independent and we are done. And so if you notice here, we didn't actually use the normality part. We could have just assumed that we have an orthogonal sequence, and that would have been good enough. Then we have an immediate corollary. So quick and dirty, corollary 628. If the dimension of V is equal to n, so in other words, if V is a finite dimensional vector space with dimension n, then an orthonormal list, an orthonormal list of length dim V is a basis. And so this is just combining the previous result with the idea back from chapter 2.A or B that if you have an independent list of the right length, then it's a basis. And so now we can define what an orthonormal basis is. An orthonormal basis, which will be henceforth abbreviated by ONB. And I don't even have to write this down. I could leave it up to you to write it down and be 99% confident that you'd complete the rest of the definition correctly. Guess what? It's a basis that's orthonormal. All right, that's it.